lately. Okay. So let's take a look at polynomial inequalities. So I will start with something that's relatively simple. Yes, and this will be posted tomorrow. Yeah, I've hit record. I will definitely post this tomorrow. So I'm going to start with x squared minus 3 less than 0. So we call this a polynomial inequality because what we have on here, this is a polynomial because it's basically greater than it's not linears are polynomials, but it's got x's, things added on. And then we have an inequality symbol. And that just means that it's a symbol that's not the equal sign. That's all that the word inequality means. So one way that we can think about these is, so let's think about the polynomial as a graph. Whoops. X squared minus 3 as a graph. So if we were graphing this, we would have y squared minus 3. So if you had an equation and you graph it, you set it equal to y. So I'm going to graph this by hand. I'm going to sketch what this will look like. And you can graph this on Desmos. Basically, if you graph this, it's going to look something like this. So that is x squared minus 3 if we graph it. So if we have x squared minus 3 less than 0, so this is asking where is an x squared minus 3 y less than 0? Or our y values are negative. So if you're thinking about an inequality here, if you have some polynomial and that's your y that you're graphing, we're asking where is the y negative? So everything underneath here, this is the negative area of the y-axis. So we're saying where is our graph negative? Where is it below the x-axis there? And that is in this section right here. Our graph is below 0 for this section of the graph. So when you're solving a polynomial inequalities, you're looking for the x's on either side of that section. So if we want to know what is this x value right here, or what is this x value right here, because we know in between those two x values, so in between these x values, our graph is below the y-axis and it's in the negative area. So when we're solving a polynomial inequality, that's what we're looking for. We're looking for these x values that make this inequality true, whether it's less than 0, which means it's below the y-axis, or maybe it's greater than 0. That's what we're looking for. So for this particular example, in order to do this, in order to solve a polynomial inequality, we generally will factor if possible. And if we can't factor, then we use the quadratic formula. So we're going to, so our step 1 is first try to factor. And if it can't be factored, then we use the quadratic formula. Or solve some other way. So we don't have to use the quadratic formula. If you like to complete the square, you can complete the square. But that's the first step, is you're trying to, what we really want to do here is we want to solve for where this is equal to 0. So if you think of it, our y is equal to 0. So where x squared minus 3 is equal to 0. That's our first step, is we want to know where is it equal to 0, because it's equal to 0 at these two endpoints. So we need to find where those 0 points are. So we have x squared minus 3. We want to know where is this equal to 0. In this case, this is something that we can solve by taking square roots, because we don't have an x term. So we would be doing that by adding 3 to both sides. So when I do that, I get x squared equals 3. So now I'm solving where this is equal to 0, and I want to take the square root of both sides to solve for x. So I'm going to take the square root. This gives me x equals plus or minus the square root of 3. So I have two x values. So if I go back to my graph, we now know one of these is negative square root of 3. The other one is positive square root of 3. So we've just solved for where those two values are. So if I go back to my graph, and we want to think about the answer to where we're less than 0 with the graph, then our graph is below y equals 0. It's in the negative portion between those two x values. So x minus x squared minus 3 is less than 0 between negative square root of 3 and square root of 3. So those are the x values that our graph is in between. We write these as in interval notation because our graph is below 0 and there's lots of answers. Everywhere that I've highlighted is orange. Everywhere in there we're below 0. We're below the y-axis. So we would write this as negative square root of 3 to square root of 3 in interval notation. And these parentheses, we use parentheses because we have a less than symbol. If it has a less than or equal to, it would be brackets, but we have a less than symbol, so we have parentheses. So graphically, we can graph what we have, and we can find that the answer is from negative square root of 3 to square root of 3. But we also want to find this without having to graph, so that you can do it using algebra. So going back to that, our first step was to try to factor or solve so we can get our x values. Step 2 is to make a sign chart. So the sign chart is basically telling you, is the y value going to be positive or negative? That's what our sign chart does. So I always start, we're looking at our x-axis here. So we're looking at a number line with x. And we know that 0 is in the middle. And what we do is we take the values that we solve for x, and we put those on here as well. So we got x equals negative square root of 3, and we got x equals the square root of 3. When we're making a sign chart, it's usually helpful to find the decimal value. So I'm going to just find out what the decimal value of that is. So we got negative 1.7, and then this will be positive 1.7. So that kind of helps me so I know where to put them on my sign chart. So I'm going to label this negative 1.7 and 1.7. So I put 0 on there just because we put 0 on our number line, but then I put my two values for x that I've solved for. Now the next step is we want to kind of indicate our breakpoints. So our breakpoints are at these values that we solve for. So those are breakpoints, and we basically draw horizontal or vertical lines there. We draw a solid line if it's a less than or equal to or a greater than or equal to, or a dashed line if it's less than or greater than. So because we have a less than, we're going to draw dashed lines because that's telling us that these values don't count because these are where it's equal to 0 and we want to know where it's less than 0. So our dashed line is, we're using this because it's a less than symbol. So we're just indicating that our endpoints don't count. So I've just kind of separated this out. Then this is the tricky part when you have something that doesn't factor. So we have x minus the square root of 3, or x equals negative square root of 3. X equals the square root of 3. And let's just look at this as the decimal version because that's going to be good enough. So let's say x equals negative 1.7, x equals 1.7. When we make our sign chart, we want to look at these as if they are equal to 0. So we're kind of undoing the solving. So I'm kind of putting them back so that one side is equal to 0. So for one of the equations, I'm adding 1.7. The other one, I'm subtracting 1.7. So this gives me x plus 1.7 equals 0. And then we get x minus 1.7 equals 0. These sort of approximate a factored form, but it's not perfect because we rounded. So we're basically trying to sort of put it back in a factored form, but we rounded because it just makes it easier to work with. If you have an example that factors, you don't have to go through this big mess. But once you've figured out what the factors are, I'm going to write these on the side of my little chart. So I have x plus 1.7, and then underneath it I'm going to write x minus 1.7. Now what I want to do is I've got 3 sections of my chart here. There are 3 areas on my number line, and I want to plug in a number on each side of the number line into my factored expression, into my factor. So the left section we have is the numbers that are smaller than negative 1.7 on the number line. So numbers to the left of negative 1.7 are numbers smaller, and you want to pick one of those numbers. You can pick any number you want. I usually try to pick an easy one. So let's say we pick negative 2. So we know that negative 2 is in this section of the graph. So what you're going to do is pick an x value here, x equals negative 2, plug it into our factors here, find what the answer is, and then just write down the sign, whether it's positive or negative. We don't care about the number. We just want to know, is it going to be a positive or negative number? So if I plug negative 2 into x for x plus 1.7, I have negative 2 plus 1.7, and that gives me a negative 0.3. So that gave me a negative, so I'm going to just write a negative sign there. Then I'm going to do the same thing with the x minus 1.7. So if I plug in -2, then I subtract 1.7, I get a -3.7, so that is also negative. Once you've filled in those, below it you multiply. So you have multiplication underneath the chart. Because multiplying these together is our factored form, and that gets us approximately back to our original polynomial here. So you multiply the signs. A negative times a negative is a positive. So I'm going to write positive right there, because you multiply those two, you get a positive. Once I fill that in, I'm going to go into the middle section. Now what's really nice is I know that 0 is in between -1.7 and 1.7, so let's use 0, because that's really easy to plug in for x. So if I plug 0 in for x into the x plus 1.7, I get 0 plus 1.7, which gives me 1.7. So that's going to be positive. So I get a positive number out. If I plug 0 into x minus 1.7, I get -1.7, so I have a negative sign. And a positive times a negative gives me a negative, so I'm going to write a negative sign underneath. Now the last section, which is the section on the right, I want to pick a number that's larger than 1.7. So let's say maybe we pick 2. It's bigger than 1.7. So let's plug in 2. So if x plus 1.7 has x equals 2, 2 plus 1.7 is 3.7, so that's going to give me a positive number. I plug 2 into x minus 1.7. That gives me 0.3, which is also positive. So then a positive times a positive gives me a positive number. So now I filled in my sign chart, and I go back to what I was looking for here. Our original polynomial, we wanted it to be less than 0. As I have in my graph, that's where your y is less than 0, or your y values are negative. Basically, we're looking for where do we get negative values. So you look at the bottom of your sign chart. Where do you have negative values? In this section right here. Those came out negative. So if you're looking at your number line, we'd be negative right here, and we are not including our endpoints, so those would be parentheses. So your answer would be a parenthesis -1.7 to 1.7. But we had a rounded. 1.7 was an approximation for the square root of 3. So really, we get negative square root of 3 and the square root of 3. And that matches with the answer we got when you look at the graph. When you look at the graph, we found where it was equal to 0. And then on that graph, the parts that are below 0 on the y-axis are between those two areas. So that is how you solve a polynomial inequality, or sort of explains, I'm trying to get all of these on one screen, but that's way too small. So, but that's how you would solve something like x squared minus 3 is less than 0. So you have a graph so you can kind of visualize what's happening. But then we also first try to factor, find where it's equal to 0, and then we make this chart, and then based off of the chart we can find our answers. And what's really, really important is the inequality symbol. The fact that it's less than here is really important. If it was a greater than symbol, your chart would be the same, but then you would be looking for the positive values instead. So the chart is important because that tells you whether you're looking for the positive or the negative when you make your chart. And then that tells you what your answers are going to be because it changes based off of the inequality symbol. And whether it is a less than or equal to or a greater than or equal to, that changes also whether you're going to use parentheses or brackets. So those really, really matter. Are there any questions? I know some of you came in while I had already started this, so you kind of missed the beginning part, but hopefully you were able to catch on. I'm not seeing any questions. For the rational inequalities, it's the same sort of idea. You're looking for where the top is equal to 0, where the bottom is equal to 0. You make a sign chart, but you're looking for the division. Okay, so Angela says you missed all of it. Well, good thing is that this is recorded, so you can view it tomorrow. I just wanted to start with this, which is actually something from week 3. I know we started week 4, but this is something that I know a lot of people struggle with, and I had gotten a request to go over this. So hopefully this was helpful. Do you guys have anything that you've been struggling with so far that you want to see me go over from any of the weeks, whether, week 1, week 2, week 3, maybe you've started looking at week 4 stuff already? Is there anything that you want to see? Question 2 from last week's assignment. Okay. Let me pull that up. The softball one. Ah, yes. Okay. So so we throw a softball straight up in the air. So this one's a good one because you're going to be looking at this again for week 5. So you throw a softball straight up into the air at a velocity of 30 feet per second. You release the softball at a height of 5.8 feet and catch it when it falls back to a height of 6.2 feet. Use the position equation to write a mathematical model for the height of the softball. So we've got the position equation here. I'm going to just highlight this. This is something that is given in the textbook. Let me bring the textbook over. So I think this is in 1.4 where it talked about the applications of the quadratic formula or the quadratic equation. So I'm going to go to applications. And so it didn't start the verb. So I'm going to scroll here. I have it highlighted in my book. This is the position equation. And it ignores air resistance. So in this equation, S represents the height of the object in feet. So it uses S because this is an equation used in physics, and physics uses S to represent distance instead of H for height. So it's a physics equation, but we use algebra on it. V0 is pronounced V naught, represents the initial velocity of the object in feet per second. And then S naught represents the initial height of the object in feet. And then T represents the time in seconds. So that is the equation. We're plugging in the initial velocity, the initial height, and that's all we need to plug in. So our starting equation, we have s equals negative 16t squared plus v naught t plus s naught. So v naught is the initial velocity. So they actually give us this information here because we throw it up at a velocity of 30 feet per second. So that's going to be the number that goes in v naught. S naught is the initial height. So that is the height where we start throwing the softball. So they give us that as well. That is, it says release the softball at a height of 5.8 feet. So that is our S naught. So when we write our mathematical model, we are just plugging in those numbers. And I'm going to just give myself an extra space here. There we go. So this gives us S equals negative 16t squared plus 30t plus 5.8. All it says is to write a model. A model is an equation that relates to real life. So you don't have to do any solving. You don't have to worry about the height for when it falls back. All you care about is writing that model. So that's how we use the position equation to write this mathematical model. A lot of people do extra work. I'm going to open up Desmo so I can just graph this for you. I could graph it by hand, but it's probably easier in Desmos. So I've got negative 16t squared plus 30t plus 5.8. So this is what the graph looks like. And I'm going to just adjust that. I don't need my x to go to 35. Let's see, there we go. Angela, do you have a question?
Yes, and I can't type it out. So it'd take too long. So I'm seeing this, and clearly I overlooked it doing everything because I went on the hunt for it, and I went to physics. I was looking for it in I could online, and what I ended up finding, of course, I ended up solving it, but I'm sure it was not that formula. It was, now I can't even think of it, but it had to do with gravity and everything else, and it was so complicated and supposed to be that simple.
This equation actually does come from gravity. Gravity is actually involved. Let me get my, oops, I accidentally muted you guys. I'm trying to get my, oh, I'm hitting the wrong button. So I'll just open this back up. So this is way more than you need to know for this problem. But the actual equation is negative 1/2 a t squared plus v naught t plus s naught. So that is the actual equation. And that's what's used in physics. Physics usually does stuff in metric, so their values are in meters per second versus feet per second, which makes more sense for us. Now, A is acceleration due to gravity. So in US units, A is actually equal to 32 feet per second squared. So that is the acceleration of gravity. In metric, it's 9.8 meters per second squared. So when you plug that number in to the negative 1/2, and you plug that in for A, and that's actually what we're going to be doing in week 5 for the discussion, that's where you get the negative 16t squared. So basically, the position equation is already converted to US units for you, where it already takes into account gravity. All you have to do is put in the velocity and then the speed. Now, if you want to know where this equation comes from, this equation right here that I put the arrow, you need calculus for that. And that is way beyond you guys. You guys don't need to know calculus. We don't have to go into that. But if you have, you know, that's like you have several classes to go to calculus, but calculus is how that equation comes into play. But we're not going to make you guys do that. Just know that there is a reason that that's the equation, and it does use gravity. And this equation is actually very accurate for, you know, even though it ignores wind speed and things like that, it's actually pretty accurate as long as you're throwing things straight up in the air and coming back down. So there's actually mathematical data. I think actually our textbook has some data that you can download, and it will come up with a very similar equation. The equation actually fits it very well. So does that help, Angela?
The simplicity of it, yes.
I imagine the stuff that you found on physics websites were probably doing calculus to show you where it came from.
I'm not sure. I know I had distance equals velocity divided by 2 times time, and time equals negative v divided by g. In essence, I ended up with, because I converted from feet to inches, so it can therefore, because it was, I don't know, because it gave me meters and I needed to get to inches.
Because it gave it to you in the other units.
Correct. So, and I mean, you're going to see what my assignment looks like, or whoever's writing it, and they're probably going to laugh, and that's great. But I came up with the distance.
You know, you can resubmit, and if you resubmit before it's been graded, that does not count as one of your resubmissions with a penalty. So if you want to fix it tonight before it gets graded, you can take advantage of that.
I think that sounds like a great idea right now.
Yeah. But we're definitely going to be looking at this again. And actually, let's see, I'm going to bring up the classroom here. If we go to our discussion, so I said for week 5. So week 4, we're not working with this, but week 5, here it is. There's that same equation. We're just giving it has, when it's in this form with the A and everything, we call it the projectile motion equation, but it's the same equation. So you can see I'm sort of explaining the 32 feet per second squared, and I'm kind of, you know, I'm plugging it in, and I'm basically going through what I just demonstrated. But we're going to be using this same equation, and we're plugging in numbers for the velocity, for the height, just like we did, and then we're going to be using the quadratic formula on it. So, you're going to be creating an equation like this, and then doing the quadratic formula. So this will be familiar to you, so you're going to want to save this because it will pop up again. But we'll be using it to model the height of a baseball, basically. It's very similar to this. So it's like we're prepping you for the discussion by throwing this equation into the assignment. What other questions do you guys have? Yeah, I hope you nailed it too.
Okay, so I see I'm probably the chatter box here. Oh, never mind. I see Cassandra. Go ahead. I'm sorry.
Okay, we'll do Cassandra's first, and then we can do yours. How about that? We'll alternate. Okay, so week 3 assignment number 1. Which number 1 has multiple 1A? Okay. So this one, so we have a quadratic because we have an x squared, but it's not in standard form. Standard form has our highest exponent first, and then we count down. So we need to actually rearrange this. So the 3x squared needs to be first. Then I need the x part. So I'm going to have a minus 4x and then a minus 20 equals 0. And then from here, you want to solve. So you can choose to solve by factoring, if it's possible, or you could do the quadratic formula. I don't recommend completing the square because it's just too much work. So you can do either one. I'm going to just do a quick poll. You guys can tell me which method do you want, because it depends on what methods you struggle with. So, because this one can be done either way. So we can either do it by factoring or the quadratic formula. So a poll should have popped up on your screen. Pick one of the methods that you want me to see demonstrate for this one. We've got a tie so far. Okay, we've got factoring, 2 to 1 for factoring. DeAndre also says factoring. So it looks like factoring is the winner here. And I know that most people do struggle with factoring, so I'll do that. And this actually, I'm going to need more room here. So I'm going to, oh, I hate that it does this. There we go. I'm just going to give myself more than enough room. Okay, so when I factor and I have a number in front of the x squared, I don't like to do guessing and checking. I prefer to do the grouping method. And the grouping method involves taking the first and the last numbers, and we're going to multiply those together. So I'm going to just use this space over here and just delete that. So I'm going to take my 3 and I'm going to multiply it by a negative 20. And so that gives me a negative 60. Now what I'm going to do is write down all of the pairs of numbers that multiply to negative 60. So I'm just going to write every single thing that multiplies to negative 60, all the pairs. So 1 and 60. I'm going to ignore the negative sign for now. 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, and those are all of them. So my middle number is negative. So if the middle number is negative, then the biggest number of each of these is negative. So I'm going to add negative signs to each of those. And those are negative because I need to multiply it to a negative. So at least, so one of them has to be negative. So now I want to look for the pair that when you add them together, you get negative 4, that middle number that I have not highlighted. So that gives me negative 59, negative 28, negative 17, negative 11, negative 7, negative 4. So I have found my pair of numbers. So I needed to find numbers that multiply to negative 60 and then add to negative 4. So I'm going to highlight that negative 4. That's what we're looking for here. And what we're going to do is we're going to split negative 4 up so that it's a 6 and a minus 10. So I have my 3x squared, and then instead of writing negative 4, I'm going to put plus 6x plus negative 10x minus 20 equals 0. So I split the negative 4 up, so now it's two things, but they still add to negative 4. And I knew those had to have x's because they have to be a negative 4x. Now the next is the grouping step. So that's just where you put parentheses around the first two and the last two, and you need to make sure there's a plus sign in between. So that's why I wrote a plus and then the negative 10, because you have to write a plus in between. If you don't have that plus sign, then what you are saying is that you're multiplying those and we're not, because these are actually added together. Once you've grouped, you want to find the greatest common factor for each pair. So I'm going to remove my yellow highlight so it's not too confusing. If it'll let me, there we go. So I'm going to look at each, go away, each pair. So the first pair, let me just write my greatest common factor is what can I factor out? So they both have an x, And out of the numbers 3 and 6, the biggest number I can divide out of both numbers is 3. So my GCF is going to be 3x. Then I'm going to look at my second pair of numbers. If the first number in that pair is negative, my GCF is going to be negative. I look at the numbers out of 10 and 20. The biggest number I can divide out is 10. And then I can't take out a variable because there's no variable in the negative 20. So my GCF is just going to be negative 10. So now I'm going to factor those out. So I'm going to have a 3x in front for the first pair, and then I'm dividing everything by 3x. So the 3x squared divided by 3x, the 3's cancel, I'm losing an x, so I'm left with an x. And then 6x divided by 3x, 6 divided by 3 is 2, and then the x cancels, so I'm left with x plus 2. Then I have my plus sign. Now, in the second pairing, I'm dividing everything by negative 10. So negative 10x divided by negative 10 is a positive x. Negative 20 divided by negative 10 is a positive 2. You know that you've done this part correctly when the things in parentheses match. If those don't match, that means you made a mistake. So from there, you have the things that match. That's going to be one of your sets of factors. So one of them is going to be x plus 2. The second factor is what's in front. So we have a 3x, and if we don't have a number in front of the parentheses, oh, we do, I just forgot to write it. That should be negative 10. If you don't have a number, you put a 1, but we do, I just forgot to write my negative 10 there when I factored it out. So then that would be a 3x minus 10. And then that gets you your factored form. So we just factored, so now we need to solve by factoring. So your first step is to do the factoring. So this process is called factoring by grouping. It's also called the AC method because you're multiplying A and C together. From here, you just set each factor equal to 0. So you have x plus 2 equal to 0, 3x minus 10 equal to 0, and then you solve for x. So I'd be subtracting 2 from both sides for the first equation, which gives me x equals negative 2. Second one, I'm adding 10 to both sides. So I get 3x equals 10. There's the 1. And then I need to divide both sides by 3. And this gives me x equals 10 over 3 as my second answer. So now I've solved that by factoring. And you would get the same answers if you use the quadratic formula. So I can zoom out so you can kind of see all of that together. So we had to first rewrite it so that it was in the right form. And then we factored, and then we solved. Cassie, did you get the same answer even though you did it differently? Oh, I hear a really loud TV.
Oh, sorry.
Yeah, you could just type that the TV came in really loud. Does that help?
Okay. I used what is it? The x equals minus b.
Mm-hmm.
Was
the
it
quadratic
plus
formula?
Or, yeah, I used that one, and I came out with 4. I got 2 answers.
Okay.
And it was 4 plus the square root of 8, and then, x equals 4 plus the square root of 8, and then x equals 4 negative square root of 8. It was a plus and a.
So somewhere in your quadratic formula you had a mistake then, because you should get these two answers. So I will do that on the right here so we can see where that mistake may be, what maybe have gone wrong there. That's probably a sign or multiplication error. So if we're using the quadratic formula, if x equals negative b plus or minus b squared minus 4ac, and that's all inside the square root, and then 2a. So b is what I've highlighted in yellow. That's negative 4. So I have negative, and then actually, because it says negative b, so I have a negative, and then b is negative 4, so I have two negatives there. Plus or minus my b squared is negative 4 squared. Then I have minus 4. Now a is numbered in front of the x squared, so a is going to be 3, and then c is the last number, so that's negative 20. And then this is over 2 times a, and a is again 3. So now I want to simplify this. So I have a negative, negative 4. Those cancel, so that leaves a positive 4. Inside the square root, negative 4 squared gives you a positive 16. And then I have a negative 4 times 3 times a negative 20. So I can do that all in my calculator. And you're going to get a positive 240. And then on the denominator, 2 times 3 is 6.
That's why I messed up at right there.
Okay, yeah. It's
Yep,
usually
that's why I messed up there.
it's usually multiplication error, or maybe you're accidentally adding something. That's usually where things happen. That's why I don't like to do the quadratic formula if I can factor, because I make more mistakes with the quadratic formula than I do when I factor. So I try to factor whenever possible, because otherwise you end up with these nasty numbers. So I'll continue just so we could see how this works out. So when you add 16 and 240, you get 256. And when you do that on your calculator, the square root of 256 gives you a whole number. That gives you 16. So you end up with x equals 4 plus or minus 16 over 6. So from here, we're going to set up two equations, one with the plus and then one with the minus. So with the plus, 4 plus 16 is 20. So that'd be 20 over 6, which you can divide both the top and the bottom by 2. That gives you your 10/3. The second one, 4 minus 16, that's negative 12 over 6, and that gives you your negative 2. So you get the same answer. And if you don't, it's usually just a math error somewhere. You added wrong or multiplied wrong, maybe had a wrong sign, because that happens a lot. Maybe forgot to multiply by a number. There's lots of possible errors. But you do end up with the same answers no matter which method you choose. So Angela, good. I'm glad you can see that. And Angela, you had a question. What is your question on?
So in last week, I think it was, on some of the videos that I saw, it was, I don't even know what the example is, but it's where you put the lines that went down, and then you did a positive, negative, positive, and it was about the integers, I believe. in reference to, yes, that.
Yeah.
The one I missed, I take.
The one you missed, yes.
There you go. Go figure. I was just trying to figure out where and how you get your positive and negatives other than, I mean, just in general knowing that between this and this is this.
You plug in numbers. So you pick a number in each area, and then you plug it in. So for this example, I'll try to highlight. So I wanted to figure out what the signs were in this area that I've highlighted. And those are numbers that are smaller than negative 1.7. So I pick a number that's smaller than negative 1.7. So I picked negative 2. So you plug in negative 2 into x for your two factors, and then you write down the sign of the answer that comes out. And so that's where I got negatives here, because I plugged in negative 2 into negative 2 plus 1.7 and negative 2 minus 1.7. I got negatives both times. And then you multiply them going down, and the negative times negative gives you a positive. So you pick a number in the section, and you can pick any number you want. So I picked negative 2. I could have picked negative 3, negative 4, negative 10, anywhere in that area of the number line. Then you do it again in the middle. So I picked 0 in the middle here because that's an easy number to plug in, because 0 is between negative 1.7 and 1.7. So then I plugged in 0. And then you want to pick a number on the other side of 1.7. So I picked 2, but I could have picked 10. I could have picked 100. You just want to pick a number in that section of the number line. So you can pick any number to figure out the signs. And then once you pick that number, you plug it in, and then that tells you whether you're going to write a plus or a minus based off of if your sign, your number, your answer is positive or negative. Does that help? Or answer your question? Okay, yeah. So the signs, I think if I am, I'm going to bring up the textbook. I think what the textbook does, I don't think they make that chart. They do a true false kind of thing. And they're still plugging in numbers. So here, like, you could plug in like negative 2 here, but they're plugging the number into this whole thing. And I find it a lot easier to plug it into the factored form and then just to multiply, or because it's just smaller things. You know, they plug it into the original. I plug it into the factored form. And I do it this way because this is the same sort of method that you use in calculus. And I know about half of our students have to go on to calculus. So I figure if I use a method that seems a little bit easier for me, you know, you have smaller numbers, it's easier to plug in, and it's going to be useful down the road. I figure that's a better method than what the book does, where it's just doing kind of one chart and just plugging in a single number into it. I don't think. He does a single chart here, and I just don't like that method. You can see they don't even like kind of make a nice picture. They're showing you what number they plug in. They don't explain why. Like here, they're plugging in negative 3 because it's between negative infinity and negative 2. It's basically in that part of the number line. So they're doing the same concept, just they're just looking at it together while I'm looking at it piece by piece.
I think where I was mostly messing up with a lot of this is off of our first introduction to you. You had said that you didn't really like how the book explained things, and to follow your video.
Yeah, I don't. I really don't.
So I have kind of dismissed the book, and I think I need to go back to looking at the book a little bit. Clearly, it has some stuff. So yeah. I will.
I would say use the book to fill in the gaps that you're not getting from me. That's because there are some, I don't have a chance to cover everything. If I covered everything in Bookhand, I think I'd have like 10 hours of videos a week, which would be, you know, it would be a lot. But I would definitely use it if there's something that my videos are not giving you and you're still missing something. I would go back to the book and see if maybe they have a different method, because it's possible that my method doesn't work for you. It seems to work for most students, which is why I just say, you know, just forget the book. But doesn't work for all. So, you know, don't use it if you can't find it for me. It's probably in the book. It's just harder to find.
Understood. I think the problem is with most things in life and in any subject, you don't know you have it wrong until somebody tells you that you're wrong. So until I know I'm wrong, I think I'm doing right. And so I'm going by your videos, and I've missed a few things along the way. But I will be tapping both of them now. Thank you.
Yeah, that's actually why the quiz a material week behind, because that way you can at least get your assignment back before you take the quiz. So that way you can find out, oh, I thought I got this and I didn't, and you can try to fix it. And then, you know, before you take the quiz. So that is one of the reasons why those don't line up. Another thing that do help some people is the textbook has a website. And you may have discovered this. It's this Calc Chat, and it shows steps. So if I go to Chapter 1, Section 7, and if you want the review problems, those are Section R. When it says Section R, those are the review problems. I'm going to just pick a problem here. Oh, that's not a helpful one. That's just, that is also linear. Okay. That is, am I in the wrong book? Like, this is not matching. Oh, I'm in the right book. Chapter 1, Section 7. These are all linear ones. Oh, maybe I'm in 1. That's 8. I was in the wrong section. That's why. Let me find a problem. Okay. So you can also kind of see how the book does it, because they show you step by step. So they're showing you their inequality. They're not really showing everything. Like they're not writing what happened from one step to the other, but at least you can kind of take a look to see if you're on the right track. And you can see that they're sort of making a chart here with the way that it's set up, not quite, but then they're showing their graph. So that's an option as well. So I think when you click on like it's textbook videos, it takes you to this website or it takes you somewhere here. Yeah. So there's lots of things here, more than enough resources. So if you're finding maybe my video is not working, there's other resources you can use. So I know that I don't work for everybody. The explanations aren't perfect. So you want to find what works for the way you learn, because everybody learns different. So. And that brings us to 8 o'clock. So this was a very, very full section, full hour. Hopefully this has helped you guys. I am going to definitely email this out tomorrow morning. So you guys will get that. And hopefully you found at least some things that are helpful. And if there are steps that you're missing along the way, even like if in my videos or something, you can always email me and ask me, how did you go from here to here? Or how did you do this? You know, that's what I'm here for. So, all right, let's stop the recording.